So, guys, the second chapter, wave theory. We are studying about Huygens wave theory, and I'm talking about the different postulates. And so, first postulate of light, Huygens wave theory is basically postulate number one. Light travels in the form of a wavefront in a medium. Now, what is a wavefront of a light beam? Let's have a clear understanding on this. अभी भी खत्म नहीं हुआ है ना. So postulates are still, some more postulates are there. The wavefront of a light beam. What is a wavefront? Basically, you can write it is a cross-sectional plane of a light beam in which all the points on this plane vibrate in the same phase is basically called as what? A wavefront. Okay? Or you can write it like this, or you can write it, maths people will understand this definition. The locus. Everyone understand? Maths people? Do you understand what is locus? Locus is basically a path where you can find or an equation where you can find all the uh, particles, right? Guys, just give me 2 minutes. Wait a second. So the locus of all the particles of the medium which vibrate in the same phase at a given instant of time is called as wave. Please write down the definition. Is it clear, guys? So the first postulate with Huygens gave was कि light, it travels in the form of a wavefront in a particular medium, right? So we're discussing what exactly is this wavefront is. The wavefront is a cross-sectional plane of light. So for example, suppose, uh, do you remember in electrostatics, guys? Do you remember in electrostatics if there was a point charge over here, let's say positive charge? So you basically took out the lines like this, right? किसी को याद है
Yes,
ऐसा?
sir.
In so basically you since this was a point charge, so basically you had lines like this. These were your electric field lines, right? And
Yes, sir.
on these electric field lines, if you drew the equipotential surfaces, the equipotential surfaces are like this. किसी को याद है ऐसा? ये सब पढ़ाया हुआ है.
Yes, sir.
Equipotential surfaces.
Yes, sir.
Similarly, in the light also, electric field lines were also an imaginary concept, and equipotential surface were also an imaginary concept, right? Both were there to both were there to understand the nature of light, right? So similarly, in wave optics, if I have a point isotropic source of light, what do you mean by isotropic source? Isotropic means same in all directions, right? So guys, suppose if I have a point isotropic source, and this point isotropic source basically it is producing certain light rays. So what are these? These are your light rays, right? Yes or no? This point isotropic source will produce light rays in all possible directions, right? So basically, again, I can draw surfaces which are perpendicular to these lines and these surfaces, or basically the cross sectional planes, are basically called as what? Wave fronts. समझ में आएगी analogy? समझ में आई? Guys, did you understand the analogy? Just how you considered electric field lines to understand the nature of electric field in space. Similarly, to understand the waves nature in space, we use what? The concept of light ray. But to understand it in the form of wave, we have to consider its wave fronts. Okay, so these wave fronts are basically perpendicular to these light rays, just like how the equipotential surfaces were defined. The similarly wave fronts are also defined. All the points which are there on this wavefront, all points on this wavefront will have the same phase. Always remember, all points on the wavefront will have the same phase as each other. So all of them will vibrate in the same phase. ये याद रखना. This is very important in this particular. Is it clear, guys?
Yes, sir.
Now there are different types of wavefront we have, just like different light source, different sources we you had, right? Yes or no? You had different sources, right? So similarly, you will have different types of wavefront. So based upon which type of beam is it? If suppose if you have a parallel beam of light, तो छोटा बनाता हूँ. Control C, Control V, Control V, Control V, Control V, Control V. So if you have a parallel beam of light like this, then what kinds of wavefront will you have? You will have. Abhi, I'll make you write the properties of wavefront as well. Don't worry. So you will have cross-sectional planes like this. Can you see some cross-sectional planes like this, through which this light is getting perpendicular? Can you see perpendicular? Yes or no? Yes or no, guys? Can you see the light rays are perpendicular to the plane? So these are your plane wavefronts. Then if the light ray is basically, suppose if the light ray is converging in nature or diverging in nature, then you will have spherical wavefronts coming. काय झालं बोल काय झालं बोल we'll write the properties, don't worry, na. I'm just drawing this thing just like how we drew the equipotential surfaces, just similar to that we are drawing. So if you have a converging beam, then you will have wavefronts like this. Again, these wavefronts will be spherical. But can you see the convex and concave wavefront? This is a convex wavefront, and these are your concave wavefront. Is it clear, guys? So based on the type of beam, you have spherical wavefronts and plane wavefronts and all. The second type of classification is based on sources. So based on the source. Guys, have you drawn this thing?
So
Hmm. If suppose you have a point isotropic source, point isotropic source. What do you mean by point isotropic source, guys? It is producing light of equal intensities in all possible directions, right? So suppose if you have light rays like this, so if you have light rays which are produced in all possible direction, then what kind of wavefronts will you get? Guys, what kind of wavefronts will you get? You will get spherical wavefronts. Okay? So if you have a point isotropic source, so then spherical wavefronts you'll get. If you have a line source, just like a tube light, if you have a line source of light, so suppose if this is this thing, this is our source, है ना? So can you see over here, the source will produce lights in all possible direction like this. Please remember it's in a circular, है ना? ऐसा. So lights will be produced in all possible directions. So what will be the direction of the wavefront? What will be the wavefront? Will the wavefront be in the
cylindrical.
form of cylinders? Guys, can you see a cylindrical wavefront over here? Hello.
Yes, sir.
You people draw it properly, है ना? Here in this case, you will have cylindrical wavefronts. Whenever you have a light line source of light, then cylindrical wavefronts. Clear? And if the source is at infinity, then the last part, if the source is at infinity, then what kind of light rays comes from the source at infinity?
Parallel
Parallel light rays. So parallel के case में what will be the shape of the wavefronts?
plane wavefront.
So that will be plane wavefront. है ना? So please remember these are your plane wavefronts. So these are your different wavefronts which are formed. We'll write the properties of these wavefronts. Still, we are discussing the first postulate only. You know, Huygens gave his whole postulate for wavefront formation and all. Okay, is this clear, guys? Shall we write the properties of these wavefronts? First property: all points on a particular wavefront vibrate in the same phase. Points on different wavefronts may or may not be in the same phase points on different wavefronts may or may not be in the same phase. For example, suppose if I have two wavefronts for a line source, let's say there is one cylinder which I am drawing over here, and let's say another cylinder which I am drawing over here. These are cylindrical wavefronts produced by this line source, right? Yes or no? If I have, suppose this is my line source and this is illuminating, you know, this is, you know, throwing light in all possible directions. So basically, if I have two wavefronts, let's say this is your wavefront 1 and this is your wavefront 2. Please remember all the points which are there, A, B, C, D. Can you see over here, A and B will be in same phase, C and D will be in same phase, but A and C may or may not be in same phase. Is it clear? Understood the 2 points, guys? First 2 points clear?
Yes, sir.
Hmm. Third point, every wavefront produced by the source moves outwards from its source. This is one assumption which we have assumed कि हमेशा जो wavefront होता है वो बाहर की तरफ ही travel करता है. It travels, every wavefront produced by the source moves outwards from its source, or basically moves away from its source. This is what we consider, guys. Is it clear, guys? We assume that wavefronts, they always travel outwards. For example, if suppose this is the light ray going now, so these wavefronts will be traveling outside. You know, the radius of this particular thing. Just imagine this thing as suppose there is a still water and you drop a stone in it. So have you seen the ripple formation,
Yeah,
guys?
yes, sir.
Everyone sees the ripple formation, right? So basically,
Mm.
each circle is one wavefront on the surface, right? Since we are talking about waves which are formed on that surface, so it's a 2D surface. The surface of water is two-dimensional, right? And if you drop a stone in between, then that point of disturbance will act as what? The source. And you know, have you seen the ripples? The diameter of those circles becomes bigger and bigger with time. Yes or no? Each circle on that ripple basically is a wavefront. And that wavefront, can you see, travels forward in the outward direction? Yes or no? Are hayana. So basically, that's the, you know, logic behind this wavefront and all. In an outward direction, the speed with which wavefront moves is equal to the speed of the wave. So guys, suppose if there is any wave and it travels with a speed v, so if I try to form, you know, the wavefronts for this particular wave, so wavefronts will also travel with, wavefront for this wave will also travel with same speed v. Is it clear, guys? ये क्लियर है वाला पॉइंट?
Yes, sir.
Fifth point is the wavefronts are surfaces drawn perpendicular to the light rays. Or always remember, the light rays will be always penetrating. Light rays will always be perpendicular to the wavefront. Is it clear? Always remember our light rays will always be perpendicular to the wave fronts. Is this clear? Is it clear, guys?
Yes, sir.
Acha. Can anyone tell me what is the direction of the in which the energy travels? The direction in which the energy travel is in the direction of ray of light, right? So can I say for
Yeah.
the wave fronts, the energy of the wave travels perpendicular to the wave fronts. That is basically in the direction perpendicular to the wave. So always remember the direction of energy, the direction in which the light energy will travel will always be in the perpendicular direction to the wavefront, or always be in the direction of the ray of light. Is it clear?
Yes, sir.
So basically this is all about your wavefronts, है ना? Acha, one more point, last. Whenever we talk about isotropic source, so isotropic source basically means same intensity, same everything, right? So there is one more point: the time taken by light to travel from one wavefront to another is the same along any ray from the same source. Is it clear? Is it clear, guys? If the light ray is from the same source, then the time taken will be same. Is it clear? Is wavefront clear to everyone? Is the first postulate clear? First postulate
Yes,
of
sir.
Huygens about wavefronts. The second postulate which he gave was for its propagation. Okay. The second postulate was given regarding the propagation of wavefronts. ठीक है? Shall we discuss this in today's class or in the next class? Because it's a little bit. अभी कर लेते हैं, कभी possible होता है तो. Let's do it. So propagation of wavefront. For this he gave two template, two postulates. मतलब basically write down every point on a wavefront in a light beam, any kind of beam it is, whether it's a parallel beam, converging, diverging, doesn't matter. So every point on a particular wavefront in a light beam acts as the sources of new disturbances which can get created in the medium. These sources lying on a wavefront are called as secondary sources. Okay, so basically, अच्छा ये मैं बाद में लिखवाऊंगा ना, बाद में I'll explain it later on, just write as of now. Every point on a wavefront in a light beam acts as the source of new disturbances which can get created in the medium. And ये जो भी sources होंगे which are lying on that particular wavefront, they basically called as what? The secondary sources for. ठीक है? Is it clear?
Yes, sir.
अब क्या होगा, these sources, all of them, they are points, right? So every point, all of them, they behave as a new point source, right? These sources are assumed to be having same frequency as that of the primary source, or basically as that of the wave, right? This is not the second point. Now the second point will come. So generally we assume that these particles are there. These are imaginary, although everything is imaginary, but still we concept theoretically we write it like this. So these sources are assumed to be having same frequency as that of the wave, and the wave generated from these source. Now these source produces spherical wavefront of their own. These spherical wavefronts created by the secondary sources are called as secondary wavelets. Okay. अच्छा हाँ, one more point you can write about these secondary sources. All points, अरे ये तो लिख ही दिया था ना मैं. All points on a wavefront, they are acting as the same. So all the secondary sources will vibrate in the same phase, right? Now I'll give you example how. So basically, suppose guys, if you have light ray like this, and like this. If you have light rays like this, and this, and if you have light rays like this, and this. So guys, can you see over here? I can draw a wavefront like this. Can everyone see this wavefront? Can everyone see this wavefront? And can everyone see this wavefront?
Yes, sir.
You know? So basically, this is the wavefront which we are talking about. Now every point on this wavefront, let's say this is 1 point, this is 1 point, and this is 1 point. Can you see 3 points on this wavefront? Similarly, 3 points on this wavefront. Sir, why are you taking three only? Array, because I have drawn only three rays. That's why. And just for clarification, that's why. Abhi, I have not completed the whole thing. Na? Abhi, we'll have to discuss one more last point, which we'll discuss in the next class. No problem. So can you see these points, guys? These points, these are basically what these are your secondary sources which are there present on this wavefront, right? Let's name it as wavefront number 1 and wavefront number, right? Yes or no, guys?
Yes, sir.
इसको wavefront को number नहीं देते, otherwise you people might get confused in one thing. So this is our wavefront, and these are the point or the secondary sources. So basically on this one. Now what happens? These secondary sources, they produce secondary wavelets of their own. Now tell me this particular thing. If I say time, will time be same for every ray in this particular thing? Will the time be same? Time taken for any wave to move forward, will it be same for each wave, right? I told you this about in the properties. Time will be
Yes,
same. If time will
yes,
be
sir.
same, then can you see the radius of this particular thing? Can you see if this is a spherical wavefront which is formed of this particular source? This is a spherical wavefront formed on this particular source. Guys, are you able to see this?
Yes, sir.
थोड़ा सा बड़ा बना दो ताकि तुमको समझ में आए कि मैं like this. क्या everyone is getting what exactly I'm trying to draw? Can you see, guys, this blue thingy? This blue thingy is basically what? These are your secondary wavelets. Is it clear? इतना क्लियर है गाइस? गाइस इतना क्लियर है? So every point on a wavefront acts as a point of new disturbances called as secondary sources. These secondary sources, they produce something called as secondary wavelets. Can you see the radius of this particular thing will be same? So the radius is same if it's in the same time, and radius is basically equals to velocity multiplied by whatever time you've taken for this wavefronts to draw, right? So this is basically how you calculate the radius of this particular thing, velocity and the time till which you let these secondary sources, waves from secondary sources travel forward. Now third point which you will write, the if we draw a common tangential plane to these secondary wavelets, if we draw a common tangential plane to the secondary wavelets, that plane will be the new position of the wavefront, or basically it will be a new wavefront, you can say, that plane will be the new position of the wavefront after a time, after a given time interval. So guys, can you see over here, if I try to draw a tangential plane over here, so can you see if I try to draw a tangential plane, so can you see this tangential plane which is enveloping all the secondary wavelets? Can you see this tangential plane which is enveloping all the secondary wavelets? Can you see this tangential plane which is enveloping all the secondary wavelets, right? So if we draw a common tangential plane to the secondary wavelets, I'll just add one more point over here. This tangential plane should envelop all the secondary wavelets so produced, and that will be the position of a new wavefront after a time t. So basically, can you see over here, this wavefront, when you drew it after some time, it became this. So can you see this moved forward? Yes or no? Can you see this moved forward? This moved forward in the direction of light, right? Yes or no? So basically, this is the new position of the wavefront, or basically you can say another wavefront has formed, or you can say the wavefront has moved in the forward direction. It's up to you. Is it clear? And similarly, if a new wavefront is found, again, there will be points on this new wavefront which will be acting as secondary sources, right? And again, the same process will repeat. So this tangential plane will act as the new position of the wavefront after a given time interval. and all the points on this new wavefront so formed will again act as secondary sources, and the process goes on, and this is how wavefront propagate. Is it clear? Is it clear, guys? Wavefront propagation समझ में आया? Guys, did you understand wavefront propagation? I told you this particular thing now. All points on the wavefront, they are in the same phase. All points, they move with the same velocity of the wave, right? Clear है? Guys, did you understand?
Yes, sir.
ठीक है. So with this thing, I'm done with Huygens, theory for this thing wave. We'll discuss about different thing, and basically what all things which we need to discuss in wave optics, है ना? So basically this Huygens theory of propagation of wavefront, it led to a new branch of physics, and with the help of this branch of physics we studied interference of light, then we studied something called as diffraction of light, and there is one phenomena which is not related with wave optics, and that phenomena is basically called as polarization. Polarization is one phenomena which neither your light nature, particle nature could explain, or neither your wave nature can explain, right? Hello. Although we can explain it a little bit with the help of wave nature of light, we can, मतलब थोड़ा सा we can use an idea. Is it clear, guys? So basically we'll study all this thing, and we'll finish off this chapter very soon. मतलब ज़्यादा बड़ा नहीं है, थोड़ा सा है, yes I know, but it's not as big as ray optics. It's very small as compared to ray optics. So anyways, guys, is it clear? Chali, thank you very much. We'll see you again in the next class, guys.
Thank you, sir.
Okay.
Thank you, sir.
Chalo.
Yes, sir.